Alright, so today we're talking about the 6 different trig functions. You know 3 of them already, right? Sine, cosine, tangent. There are 6. So, we're going to learn about cosecant, secant, and cotangent today. Alright? So, in a right triangle there are actually 6 possible trig ratios, not just 3. You've only learned 3 already though. So, a lot of times theta or phi will be used to represent angle. We'll use theta 99% of the time. Phi won't be used very often, but that is what that means. Especially because I can't draw it, so I use theta. So, in a right triangle, like I said, there are 6 different ways to make ratios out of those. We've only known 3 so far. We know sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. The other 3 are just the reciprocals of that. The cosecant is the reciprocal of the sine. So instead of opposite over hypotenuse, it's now hypotenuse over opposite. Secant is now the reciprocal of cosine. Right? Instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And tangent is the reciprocal of cotangent. Right? Flipped over, instead of opposite over adjacent, it is now adjacent over opposite. So now you have 6 of them that you have to deal with. No, there's not a cool SOHCAHTOA thing that goes with it. It's just cosecant, secant, cotangent. So sine is sin, cosine cos, tangent tan. Cosecant is CSC. Right? Secant SCC, cotangent COT. Right? So those are the different ways we write them. They're just the reciprocals. Right? The way I like to think of it, a lot of people mix up that cosecant is with sine and secant is with cosecant. Or excuse me, secant is a cosine. There can only be one co in each group. So if it's a reciprocal, it can only have one co. So like sine is with cosecant. Cosine is with secant. And tangent is with cotangent. Alright? Any questions on that? Julio, what's up? Need the ID pass? Alright, I'll write it down in a second, bring it back there. Alright, so with that, if you look up here, the reciprocal functions. I would make sure I know that because if I want to punch like cosecant or secant or cotangent into my calculator, I'm going to have to use these reciprocals. Right? So if I want the cosecant of some angle, I'm going to use 1 over sine. Because if you look at your calculator, there's no cosecant, secant, or cotangent buttons. Alright? So like I said, they are reciprocals. Sine is the same as 1 over cosecant, cosecant 1 over sine. Things like that. Does that make sense? So far? Alright, so I want you to try this and then we'll go through it a little bit. If tangent of theta equals 3 over 4, I want you to find the other 5 different trig functions. Now I'll help you set up the triangle, but that's all I'm going to help you set up. How could I set up this triangle? Tangent of theta equals 3 over 4. Violet? 3 on the opposite. 4 on adjacent, right? Tangent is the same as opposite over adjacent. There, you need to figure out your hypotenuse, and I want you to figure out the 5 other tangent functions. Then we'll go through them. So how are you going to find that third side? What are you going to use? Pythagorean theorem. Good. So find that third side. Then you know, use your opposite, hypotenuse, and adjacent. Use your 3 sides to make your 5 trig functions. Alright, so for your third side, you should have got 5, right? Pythagorean theorem, 9 plus 16 equals c squared. 25 equals c squared, that means c is 5. Our hypotenuse is 5. So, if I'm doing sine, opposite over hypotenuse should be 3 over 5. Cosine, adjacent over hypotenuse, 4 over 5. Cosecant is the reciprocal of sine, so it's hypotenuse over opposite, or 5/3. Secant is the reciprocal of cosine, so hypotenuse over adjacent. And cotangent is the reciprocal of our tangent. It was 3/4, so I know it's going to be 4/3. Did we get all those right? Wasn't too bad, was it? Alright. Ready to keep going? You'll remember it. You're good. Alright, so now I want you to try and put something in your calculator. Like I said, you're not going to be able to punch it in as cosecant of 30 degrees. It's going to have to be 1 divided by sine of whatever the degree is. You have to use the reciprocals, so there's not actually a button on your calculator. So secant of 60 would be 1 over cosine of 60. So in my calculator, 1 divided by cosine of 60. Should get 2. Right, try the other 2 of them. Did we get answers? And what did you get for the cotangent of 58?
0.62.
0.62. Everyone agree? Yeah. Levi, did you get one for cosecant of 25?
I got 2.14.
Is that everybody else got?
Wait, I got 2.3.
Yeah, I got
Ooh, 2.37. Punch it in again quickly, Levi. Let's see what you get. Yep. Don't forget to grab a note packet. Same thing. Alright, let's see what's going on with the calculator. Are you in degree mode?
Yeah.
Alright, so what'd you get, guys? What'd you get, Paige?
2.37.
2.37? Alright. So make sure we're using the proper reciprocal, right? Cosecant reciprocal is the sine. Secant is the cosine. Tangent is the cotangent. Alright? Alright, let's try a couple of types of problems. So if we give you a triangle, right? We give you a right triangle. It has an angle marked theta. It's got all the sides recorded. We're just going to ask you, what's the value of cotangent? Well, cotangent is the reciprocal of which of our 3 original trig functions? Tangent. Right? So we want the opposite of tangent. Well, tangent is opposite over adjacent, right? So if the tangent is 12 over 5, that means the cotangent is 5 over 12. Now, obviously if you can remember that cotangent is adjacent over opposite, you don't have to write out the tangent. You'll be perfectly fine. So like the value of the secant theta. Well, secant theta is the reciprocal of cosine, right? Cosine is adjacent over hypotenuse. So this one's going to be hypotenuse over adjacent, right? It's the reciprocal of cosine. So if I look at theta, opposite, adjacent, hypotenuse. Hypotenuse over adjacent would be 13 over 5. Does that make sense? Grace?
Why do we have these?
Why do we have these? What will I do the other 3?
Just solve for value of x. You just use the other 3.
You could, but there are other times where you want to know these new 3. And also, because of the fact that there are 6 trig ratios compared to just knowing the 3, I guess it's tough. How am I trying to say this? So we're trying to show you all of the options and not just the 3 original options, or the 3 most used options, I should say. Does that make sense? Okay. Alright, making a triangle on the axis. A lot of people struggle with problems like these. Alright, I don't know why, but a lot of people do. So, when we ask you to make a triangle, what's going to happen is we're going to give you an example point. So I'm going to give you like 5, 12. So what I want you to do is I want you to plot 5, 12. Up here. That's the first step. Then what we're going to ask you is draw the triangle. What's going to happen is, your triangle, you're going to go straight down to the x-axis. Every single time. And you can use those 2 points. You're always going to the x-axis because our angle theta is always from the x-axis up to that point. Right? Theta is always from the x-axis up to that point. A lot of people try and draw that line to the y-axis and they get it wrong because they have things flipped around. The line from our point up here needs to be drawn to the x-axis. Alright, so then I'm going to figure out some lengths. Well, this one's 5, right? That's how far I went on the x-axis. This one's 12. That's how far I went on the y-axis. How do I find that third side? Pythagorean theorem, right? 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. That's 169. So c is 13. Now the more you do these, the better you'll get at them. Like 3, 4, 5 triangles. 5, 12, 13, 10, 24, 26. You'll know different right triangles. The more you do. Then, what it's going to ask you to do once you've drawn your triangle and you have all 3 side lengths, it's going to want to know the 6 different trig values. Right? It's going to ask you for that. So if theta is always the angle off of the x-axis, and the x-axis up to the point, this is always theta right here. That means 12 is my opposite, 5 is my adjacent, 13 is my hypotenuse. So, opposite over hypotenuse for sine, which means cosecant is just that flipped over, so 13 over 12. Cosine is adjacent over hypotenuse, 5 over 13. Well, secant is just the reciprocal, 13 over 5. Tangent, opposite over adjacent, 12 over 5. And then cotangent is that flipped over. Alright? Now, are there any questions on that? The one thing I will say, because it's going to come up in the next 2 problems, is if you have a negative value, say we were down here, right? We went to the x-axis, we would leave this as negative 3. Negatives matter in problems like this because they show us a direction. Alright? So when we're doing problems like this, the next 2 problems that you guys are going to try, the side lengths can be negative because that's showing us which direction we're going on our coordinate grid. It's the only time we'll ever have a negative side length. Okay? Yes. Try the next 2, please. Try again. If you get stuck, raise your hand. Actually, just try the next one. Do A first. Right? You draw your own one here. Hey guys, if you get like a ratio, a trig ratio, that can be reduced, what do you think you should do with it? Reduce it. Good. if you get an answer for one of these, you want to come put it on the board. We'll throw it up there. Any of them. Sine, cosine, tangent, cosecant, secant, cotangent.
Did you reduce?
Yep. So guys remember, theta is always the angle along the x-axis to the line we draw here. Theta is always the angle at the x-axis. What'd you ask, Liam?
Did you reduce?
Yes, you need to reduce. Reduce your fraction if you can. I just said that like 2 minutes ago, I'm pretty sure, right?
I think you did. I think you imagined you said it.
No, I literally just said that.
No.
I said if we get a fraction that we can reduce, we get a ratio that we can reduce. I said that? Yeah, I did, right? Coogie's, yeah, he heard me. Violet heard me. Because Coogie, I think, even answered my question. I said, if you get a fraction that you can reduce, what should you do with it? Coogie said reduce. What?
Why do we have to reduce that?
Because you reduce every fraction. And you reduce your ratios. Did you get answers? Do you have one on the board?
Sure.
Sure. Liam's going to put one on the board too.
Oh my god, I
apparently.
forgot which one it was.
Look at the picture and you tell me.
I forgot.
Sine is D.
I forgot what I wrote down. Oh, dang.
Perfect. So sine is negative 4 over 5. That means cosecant is going to be 5 over negative 4, right? It's the reciprocal. Take it, let's go. We don't have much time left. Go.
Killing the fun.
Yeah. Well, you guys are saying that I'm crazy and I don't say things. We'll rewind the tape, don't worry. Instant replay.
It's crazy that you care so much.
I do. Liam, leave
Can I
it
take
alone.
it?
No. Cosine, 3 over 5, which means secant is 5 over 3. I need someone to put the last one up. Anyone? Bueller.
No.
Bueller.
That's not allowed. Sure.
We can't move on until someone does it.
Willie's gonna go out there again.
Oh, Liam.
Willie's
hero.
Willie. Call me Willie.
Willie?
Call me Willie.
Slick Willie?
We have more stuff to do.
Yeah, we have more stuff to do, Jalen.
Mr. Clinton, Slick Willie.
The next problem's actually going to be a really interesting problem, too.
Oh yeah.
If we don't finish it, can we not get homework?
Wrong. Alright, hey, thanks, man.
Slick Willie.
Hey, it's fun. Let's go.
It's my autograph.
Very nice, man.
Where's mom?
Alright, so tangent's negative 4/3 means cotangent's negative 3/4. Alright, so before doing part B, we got to talk again about rationalizing a denominator. Remember we did this? We said we couldn't have any answer to the square root of the denominator. Because we don't want to round things when we do side lengths. We want exact side lengths. Right? So we're going to make simplified radical form. And we're going to rationalize denominators. Right? In math, we never leave a radical in our denominator. Instead, we rationalize it. Does anyone remember how we rationalize? We are going to multiply top and bottom by the radical in our denominator. So, if we get an answer that says 1 over the square root of 10, what I'm going to do, whatever radical's in that denominator, in this case it's square root of 10, I'm going to multiply top and bottom by the square root of 10. Because what that does, square root of 10 times square root of 10 becomes square root of 100, which is 10. It gets rid of the radical in my denominator. So to rationalize things, if you ever get a radical in your denominator, it needs to be rationalized so you get rid of it. Okay, so that would be your answer for that one then. Now, we are going to skip B, but make a note of this. Make a note of rationalizing your denominator, please. Right? I would put that like, I'd put like, remember, need to rationalize the denominator. And I'd probably write that example down right there, how to rationalize the denominator.
Is it gonna be on our homework?
I haven't even looked at it, to be honest.
Sassy.
What do you say?
He said obviously.
16. It might be, I don't know. I'd have to look through these. I haven't really looked at it, to be honest. Alright. Has everyone taken a note of that? Anyone? Okay, good. Let's try one of those other problems now. Now, these type of problems we may see a good amount of. So these problems where we're going to give you like one trig function and we want you to find 8 different trig functions. So the first one, we give you the sine of theta, which is 3 over 5. Well, sine of theta is opposite over hypotenuse. So sine of theta would be 3 over 5, where you're going to have to find that third side and then give us the next trig function. Now, there'll be times where we give you a triangle like we have now. There'll be times where you have to draw your own triangle. Right? You can do that. You know how to draw a triangle. You'll be perfectly fine. Okay? So we need to find our third side. 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. Minus 9. We have b squared is 16, which means b is going to equal what? 4, right? Take the square root of both sides. So find your third side. Then, which trig function is it asking me for? Secant theta, which is what in terms of sides? It's the reciprocal of cosine, so that means it's going to be hypotenuse over adjacent. Well, good thing we just found the adjacent, so almost like we did that on purpose.
Ow!
Shh, guys, relax.
Just stab me in the head.
Hypotenuse over adjacent is going to be 5 over 4. Okay, so that's my answer. Any questions on that? Should we do a second one really quick?
No, sure.
That one.
No.
Sure, alright, I like that answer. I like people saying no.
Oh, what the heck?
Oh, we'll do it together. Alright, given that sine equals 1 over the square root of 2. Well, once again, sine is opposite over hypotenuse. So 1 over the square root of 2. I need to find my third side. So, 1 squared plus b squared equals the square root of 2 squared. 1 plus b squared equals 2. Right? Square root of 2 squared is just 2. So, minus 1, b squared equals 1, which means when I take the square root, I get b equals 1. So both my sides are 1. Whoa, now it's asking me for cotangent over cosecant. Violet, is that a, you know what we're doing, or is that a stretch? Alright, what's going on?
So what I did was, I just kind of, so I did like the cotangent.
Okay, cotangent theta, what'd you get?
1.
You got 1.
Because it's opposite.
So it's 1 over 1, right?
Yeah.
Good.
So then you can just put 1 and then over the, what is
The cosecant.
it? Yeah.
So the cosecant was the opposite, the reciprocal of the sine, right? So hypotenuse over opposite, which equals square root of 2.
So then you can just,
So you can just do
but then you have to rationalize.
1 over square root of 2, but then we have to rationalize it. Anna, how do we rationalize it?
Multiply by 1 by the square root of 2.
Good. So, guys, find these separately, right? Find the cotangent, find the cosecant, and then put them over each other. We get square root of 2 over 2 is our final answer. Alright? Any questions? Oh, we cruised through that.